Hello friends, today we are going to understand what are the addressing modes in 8085 easily. First question, what is an addressing mode? So I'll give you a simple example here. For example, these are the three chairs. Okay, first chair location 1, second chair is location 2, and third chair is location 3. And the guys sitting on chair are, on first chair we have Arun, on second chair we have Manish, and on third chair we have Rahul. So the guys who are sitting on chair is data, and where the guy is sitting is known as address. Okay, so address is the location where your data is sitting. Okay, so again, address is a location where your data is sitting. So let's understand first what is an addressing mode. An addressing mode is a way to use the data or to access the data in the instruction. So let's say this is an instruction, okay, and here is the data in the instruction. Now how I call or refer this data in this instruction is known as the addressing mode. For example, I can call you by your name, or I can call you by your address, I can call you by your roll numbers. Okay, so these are different ways to call a person. So they are the addressing modes. So before understanding an addressing mode, you must understand what is a data. So a data is nothing but a number, and in 8085 or any controller or processor, a number can be either 8-bit or a number can be 16-bit number. Okay, so let's understand what are the 8-bit numbers. Normally we write the numbers with H. Now this H shows that the numbers are in hexadecimal format. Whenever you see only 2-digit number, for example, this all number are 2-digit numbers. These all 2-digit numbers are 8-bit numbers. FFH is the maximum number and its decimal equivalent is 255. So 255 and FFH, they are same. 00 is same as writing 00 in decimal. This is an 8-bit number. Let's call off 16-bit number. All the numbers that you write 4 digits in hex format, they are 16-bit numbers. FFFH, this is the maximum number which has the decimal equivalent of 65535. This is decimal. Okay, so this was about the number, 8-bit number and 16-bit number. So next question is, what is a programming that we talk of? A programming is ultimately you store some data and then you process it. So this is a programming. So now we'll focus on the word store, because you have to store the data first and then we'll process. So how can you store a number? So to store a number, we have two mechanisms. Either you can store the number in register, or you can store the number in an address. Okay, so what are the registers? So in 8085 we have registers which can store data. For example, A, B, C, D, E, H and L. These all registers are 8-bit and they can store your 8-bit data. So this is one way to put your numbers. For example, if you have a number 26H, it's an 8-bit number and you want to put it, you can put it in A, or you can place it in B, or you can place it in C. You can put in any registers. Second option we have is we can store the data at some address. Remember, 8085 has no internal memory. You have to put external memory. But once you put that memory, then you get the address, and on address you can store some data. For example, remember all the addresses in 8085 that we write as 16-bit addresses. Okay, so 000H is a 16-bit location, this first location and this is the last location. These all locations are 16-bit, and you can put a number on location. For example, 56 number is stored at 000H, a 92 hex is stored at the 001 location, a number 78H, that's a data which is stored at the location FFFH. So once you know that, now we can begin the understanding addressing modes. So very first mode in addressing is immediate addressing mode. So the name itself suggests it's an immediate. What is an immediate? Immediate, it means on the spot, okay, directly. So the number which you provide directly or immediately in instruction itself, that mode is known as immediate addressing mode. For example, you want to store a number 35 hex in a register, then the instruction is MVI. MVI stands for move immediate. So now you know that this number will be stored immediately in A. Okay, so the number is provided directly as a part of instruction. This is known as immediate mode. Similarly, ADI 11H, whenever you spot a letter I in the instruction, most of the time understand that that instruction is immediate. What this instruction does, ADI, it adds the number 11 with a content in register A. In A already we have stored a number 35, so this instruction will do the addition of 35H plus 11. See, the answer is 46H, which will be stored in A. Okay, so this is immediate mode instruction. A second instruction is register addressing modes. So the instructions which have register as their operand are known as the register addressing modes. For example, this instruction move A, B. Now you can see both destination and source are registers. So this instruction is data transfer using register. This is a register addressing mode, whereas the first instruction, as you can see, it is still an immediate addressing mode. Okay, so when you have registers in your instruction only, you call it register addressing mode. Please press the subscribe button and click the bell icon to get the regular updates. Third type, a direct addressing mode. Now remember, indirect addressing or indirect addressing, you have to use the address. You have to deal with address. So remember, indirect and indirect, you will be using a concept of address. So what is a direct addressing mode? See, for example, we have a number 92H. Okay, and that number is stored at location 1122H. Now this address is important because we have to deal with address here. Now you want to load a number 92H. You want to read. So at that time you have to use the load instructions. If you want to save the number at some location, then you have to use store instructions. Okay, so the first instruction, LDA, this instruction will load or read the accumulator. It will save the accumulator from where 1122. So it will read the number 92 at this location. We have a number 92H. This number will be loaded in the accumulator. So you are loading an accumulator from the location 1122H. This address is provided directly. Remember, this is an address that we are providing directly in the instructions. This is not a number, this is an address. That's why we call it a direct addressing mode. Okay, so now after this instruction is executed, a data 92H is stored in accumulator. Next instruction, you are writing store accumulator FFFFH. Now this instruction will store your accumulator, will write the data in accumulator at FFFH location. Now you understand that we have a data 92H already in A, and that number will be returned to this location FFFH. So now this number will be returned to FFFH. This is a direct addressing mode. You have an address directly available as a part of instruction. Now what is an indirect addressing mode? So understand that in direct addressing mode we had a 16-bit address which was given in the instruction. Now if we can put this address in a register pair, because it's a 16-bit address, we will need register pair to store 16-bit data. This address will put in pair, and we'll use the pair to point to an address. So it is one step more than the addressing mode. Okay, this is an indirect. So next, understand what we are doing here. We are storing 11H in B and 22 in C. So this instruction that we have written in B and C combined, you can say in B we have 11 and in C you have 22H. Now you can look at the BC pair here. In BC pair combined you have a number 11 and 22H. So what we are writing here, LDAX. Now this is of course load accumulator, but now you have X, where X shows it's a pair. So what is LDAXB? It will load accumulator from the BC pair address. You can write B here or you can write B. If you write B, it becomes BC. If you write D, it is known as, or it is taken as a DE pair. Okay, so when you write LDAXB, it will read the content from BC location, a BC data, that is 1122. From that location, here is the location, the data is 92. This 92 will be loaded or will be stored in the accumulator here. So after this instruction, your accumulator will have a data 92. So of course this is an indirect way. We'll store this number 1122 in pair first, and then we'll use the instruction LDAX. Okay, instead of writing these two instructions, you can do it in one instruction also, and that instruction is LXIB1122H. This instruction will store 16-bit directly in BC pair. So that's another way of doing it. The last mode is implicit mode. Now what is implicit? In implicit you don't have to provide anything externally. You don't have to specify what you want to do. The instruction understand is automatically. You don't have to provide register. You don't have to provide a pair. Okay, such instructions know what registers they are supposed to work with. For example, instruction CMA, you don't have to write anything with CMA. This CMA is a complete instruction, and it knows that it has to complement the data which is in register A or accumulator. Similarly, another instruction is XCHG. It doesn't have anything, no register, no address. This itself is a complete instruction. What it does, it exchanges the data which is in DE pair with HL pair. The both data will be exchanged. The data of D will come to H and H will be transferred to D. Similarly, data in E will be transferred to L and data in L will be transferred to E. So this content of DE and HL pair are exchanged. You don't have to write anything. The instruction knows it works. It is supposed to work with DE and HL. Similarly, RAL. This instruction works with accumulator only. So here also you need not specify any register or address. The instruction rotates the accumulator one bit to the left. So these instructions are known as the implicit instructions. So friends, these were the 5 addressing modes. Thank you, and please subscribe to our channel.